All right, so here we go on our homework solutions for Walsh Unit 3.3. So you should be on page 255 in your Walsh book. You should have already completed lesson 3.3 and done that while watching the video. So right now I'm going to go over solutions. So these ones are asking us to rewrite each exponential, asking us to write each exponential expression as a radical expression. So right here I have 5 to the power of 1/4. Well, my denominator becomes the root. So I'm looking at a fourth root here. And then this is going to be 5 to the first power, but I'm not really going to write that. So I have the fourth root of 5 here. So in the second problem, I've got g. I've got 2 in my numerator. That's going to be my power of g. My denominator is my root. So I'm going to have a ninth root here, and it's going to be the ninth root of g to the second power. Now, it would take 9 g's to pull one out, so that's all I can do there. Another way to say that is to say that we have the ninth root of g raised to the second power. So those are equivalent statements. So the next one here we're looking at, we have a negative. So we know that we're multiplying -1 times something. So we're multiplying -1 because order of operations tells us, guys, that this is -1 multiplied by 10 to this power. So I'm doing my exponents first. Exponents always come before multiplication in order of operations. So this is going to be -1 multiplied by this positive 10 to the 3/7. So this is going to be a seventh root here, and it's going to be the seventh root of 10 to the third power. So that's more plainly written as -7th root of 10 to the third power. The other way that I can write that here is going to be, obviously I can take my negative, it needs to be on the outside here, but then that could be the seventh root of 10 to the third power. So again, those are your equivalent values. So these next ones are asking us to rewrite the radical expression as an exponential expression. So here I have 20 to the third power, and it's the square root of it. So that means that I'm going to have a base of 20 here, and my base of 20 is going to have a power of 3, and we have a square root, so it's going to be 20 to the power of 3/2. The next one, we have a base of r here, and that base of r has a power of x, and we have a sixth root, so that's going to be x over 6. And that's apparently not an x, that's an s. So let's make that s over 6, but same thing. All right, continuing down here, it's asking us to evaluate. So you could pop that right into your calculator and you would get a value. Or you could put in, well, that is an index of 2, so that's going to be a square root of 5 to the 5th power. And when you do that, you should be getting 55 and 902 thousandths. So when you go on to our number 7 here, this obviously you could put right into your calculator, or you can convert it if you wanted. So this would be 5 to the power of, what's a third power, but our root here is a 4. So that would be 5 to the 3/4. And that's going to give us, I guess these are squiggles because it's not exactly equal to, these are estimations. 3 and 344 thousandths. So on the back here, these ones are, or on the next page, these ones are asking you to think a little bit more about why these powers work. So the first one is asking us to explain why the fourth root of a to the power 4 is equal to a using the power rule. So what you really have here is you have a to the power of 4, and a to the power of 4 is, that's an exponent, and that's a root. So we know that this is actually a to the power of 4 divided by 4, which is just a to the power of 1, which is just 1. So that's why this works, thinking about our conversion, but it's asking us to use the power rule. So it's also true that this is the fourth root of a to the fourth power raised to the power of 1. So, right, because I could say I'm taking this quantity, raising it to the first power. Well, that would actually be a to the fourth, right? So a to the fourth. But then if I'm looking here, this is going to be a power of 1 with a fourth root. So this is going to be a to the fourth, all raised to the power of 1/4. Well, the power to a power rule with exponents tells us that we multiply our power by our power. So if I have a to the fourth here and I'm multiplying it by 1/4, well, 4 multiplied by 1/4 gives us a to the first. So again, we just get a. So those are some explanations about why that is true, given some different rules about radicals and exponents. So the next one's asking us to explain how this can be equivalent to both the cubed root of 3 to the fourth power and the cubed root of 3 raised to the power of 4. So when we're looking at this right now, it's basically just because the order doesn't really matter. So the first one here is telling us to the whole thing, either way, whichever way you do it. This one is it's asking us to take this to some fourth power and then take the third root of it. So it's just two different ways of writing that. So in the first one, it's asking you to begin by taking the 3 and raising it to the fourth root, and then taking the third power of that. But in the second one, it's asking you to take the cubed root of 3 and then take that value and raise it to the fourth power. So there's no specific thing that you need to have written there, as long as you recognize that all of these are equivalent just based on the fact that this one here, so, well, okay, I guess I can work it out. All right, so if we have this first one here, it's telling us that we have 3 to the fourth power. So that is 3 to, so this right here, 3 to the fourth power, that's going to be 3 to the power of 4 over 3, which is what we started with here. Well, this one here is telling us that we have, basically, we have 3 to the power of, and then this is going to be 1/3, and then it's going to be raised to the power of 4. Well, our power to a power rule would tell us that that's 3 to the power of 4/3. So there they are, equivalent. All right, so number 10 here, it says to determine whether each of the following equalities are true or false, and if the equality is false, describe at least one way to make it true. So basically, we're looking to see if these are currently true or false. Well, right here, this is 5 to the power of 2 over 3. All right, well, I already know that 125 can be written with a base of 5, so that is really the square root of 5 to the third power. So if I take that and I go to convert it to radical or exponential form, that's 5 to the power of 3 over 2. All right, so this is false because right now we have a situation where it is the opposite of what we want. So really, if we wanted to create one that was equivalent to this, we would need to have the cubed root of 5 squared, right? Because if I pulled this out, this would be a base. I'd have a power of 2 with a root of 3. So I'd really want it to be the cubed root of 25. So that would be one way to make that one equivalent there. All right. So right now, I'm looking at 2 to the power of 2/3. Well, I know 4 can be written with a base of 2, so that's the cubed root of 2 squared. All right, well, if I go to convert that, that's going to be a base of 2. I've got a power of 2 and a root of 3, so 2 over 3. And they are, in fact, equivalent. So A was false. We went back down here. We made it true. B was true to begin with. All right, so we're moving on to C here. So for C, this is telling us that we have the square root of 81. Well, we know that the square root of 81 is actually 9, so that's saying 9 raised to the power of 1/2. Well, 9 raised to the power of 1/2 is not the same as this, so that's not going to be the same there. So another way that we could rewrite this is that we could just take the square root of 81 and then rather than raising that to the 1/2, we can raise that to the 1/4 because the square root of 81 is just going to give us 9 and we want base 9 raised to the power of 1/4. All right, so part D here, we want to know 3 to the power 6 is the same thing as the cubed root of 20, nope, the square root of 27 raised to the power 4. All right, well, I can rewrite that with the base 3. So I've got 3 to the 6th is equal to the square root of, and this is going to be 3 to the 3rd, and that's all raised to the 4th. So I'm going to start converting here. So that's going to be 3 to the 6th is equal to, I'm going to have base 3 here. So I've got a 3 with a power of 3. So this is going to give us a situation here where I've got 3 over 2. Now I'm raising that to the power of 4. So that's going to be 3 to the power of 6 is equal to 3 to the power of, well, I'm going to multiply exponents here. 3 and 4 is 12 over 2. So that is 3 to the power of 6. So D, those are in fact true. So hopefully that is clear. I don't know truly what else I could help explain about those. What you're going to do next is you're going to go into back in to get some notes. So I've emailed you a file. The file is going to be called 6-4 Instructional Notes. And then you're going to go ahead and watch the video of me working through those instructional notes. So this is basically some problems that are asking you to use the rules and to solve problems given what you've learned about converting between these forms. And what you're going to see is sometimes it's easier to work in one form, sometimes it's easier to work in another form, sometimes it's easier to do some sort of combination. But again, your next step now is to do those video notes. And then I'll also have emailed you a homework file that goes along with that. It'll be 6-4 homework, and you can work on that. Then on Monday, I'm going to post the solutions to that 6-4 homework. And it's not going to be a video. It's going to be a file worked out. But then if you want me to post a video of a certain one, you can email me and reach out about that. And then on Monday, I will post our next instructional lesson as well. I hope you guys are well. Again, please reach out if you need anything, and take care. Bye.